Hello and welcome. We are now in this tutorial going to learn how we can summarize continuous variables in R. You have seen that in one of our previous lectures we have been looking at categorical variables. We will be following pretty much the same motive, but this time I think it's a little bit of difference, and I think it's very important that we should understand that in much of our regular day-to-day data analysis, summarizing variables is very important. Summarizing categorical variables is very important. Summarizing continuous variables is also a very important task. In fact, it is the first thing that you should do once you start working with any kind of variables. So as before, let us try to get a sense of what do we mean and why should we be interested to do this in R in particular. Of course, R has got several routines and simple things that you can do with R that you can pretty much do with all other statistical data analysis software. And it still needs that you will need to understand quite a few things. And there are some quirks that we will be discussing in course of this tutorial. So that's important. What is a continuous variable? A continuous variable is one where, unlike what you get to see in categorical variables, you cannot really have a boundary conditions for the levels of the individual values. To give you a concrete example of a continuous variable is something like a person's blood sugar, for example. Certainly there is a lower boundary. There can be a very high upper boundary as well. Of course, if the lower boundary is zero, that's kind of inadmissible with life. And therefore, it is important that in between all the values, you don't really get to set boundary conditions for them. So you can't, between 1 and 2, you can have 1.5. Between 1 and 1.5, you can have 1.25. Between 1 and 1.25, you can have 1.125, and so on and so forth. We could actually narrow the gap till you have got virtually no distinction between one value and the next. So those are continuous variables. Quite obviously, the strategies that we have learned in R using the categorical variable case is not going to work with continuous variables. We have to do something else. Of course, in our day-to-day regular statistical data analysis procedure, there are things that we do in order to describe continuous variables, and the same things are available in R as well. So in this tutorial, we're going to learn that bit. So just before I get started, let me introduce you to the context of this work. As you know, my name is Arindam Basu, and I am at the University of Canterbury at Christchurch in New Zealand. And this is part of the E-Pathshala, part of the MHRD of India government. As before, we are following kind of a motive. So what we are going to do here is I'm going to read a data set, and in that data set, one of the first things that we're going to do is that we're going to find the data. So we are going to go and find the, if you will, the data sets. I mean, in that data set, which variables are continuous variables. And then we will describe a few strategies that you will get familiar with and this is going to give you a fair bit of grounding in how you can summarize continuous variables. And later on, we shall summarize the most important learning points. Kind of a motif that we have been following. It's the same thing that we've been following with the categorical variables. So those are your learning objectives. Let's now talk about what exactly are we going to do in this particular lesson. So as I said, we are going to read data, and then in the data set, we are going to find out which variables are continuous variables, and then we shall numerically summarize the continuous variables. In other words, we shall see if we can draw kind of what are some of the what do we look for when we need to summarize a continuous variable. Of course, there has to be a sense of the central tendency, and there has to be a sense of dispersion of this. We all know that for a continuous variable, a very simple mean to do that is to calculate the means of this, and we have already discussed this in one of our previous modules, that you can actually use the mean, then open a parenthesis and then close a parenthesis and type the name of the particular object that you subsetted from the data frame, and then acknowledge the fact that it can contain inadmissible or missing values. You say that there are missing values, you have to omit those missing values. In other words, you remove the missing values using na.rm and set that particular procedure to true, and then R will return you with the true mean of that particular variable. We have also learned about trimmed means and other things before. You can likewise call the median function and get a sense of the central tendency. You can get a sense of dispersion by using the var function. So you put var and then so that it is going to give you the variance of that particular continuous variable. And you can again likewise, exactly as you have done with mean, you can put that na.rm, which is removal of the non-admissible or missing values set to true, and then R, what it will do is it will remove those inadmissible and non-available values or missing values, and it'll give you the variance. And if you take a square root of the variance, you can get standard deviation, and you can certainly in the current versions of R, you can get the standard deviation using SD as a function, and then open a parenthesis and close the parentheses and pass the same parameters as mean or variance. But those are kind of individual variables, individual statistics that may or may not be quite comprehensive to let you see the larger, bigger picture, you see. So in case of categorical variables, for example, we had seen that you would really need to put together a table. So you could have individual levels of the categorical variable, and then for each level of the categorical variable, when you wanted to describe them or summarize them, each level would give you the row counts, and then from each of the row counts you could get their proportions or percentages, which you could then display, and you could get a fairly comprehensive sense of the descriptive statistics for the continuous variables. Is there something similar for R? We need that, because even though calculation of mean and standard deviation can be very useful, it is nevertheless needed that we could actually then kind of want to see a larger, big picture of this. So the other thing, therefore, is we get to see a more comprehensive and larger, bigger picture, and also we'd really like to see how would it look like kind of visually. So if we were to visualize a particular variable and its summary statistics and put them on a kind of a map, sort of a visual map, how would it look like? And this is another thing that is very important that we must be able to extract, and using nothing but R. Okay, so setting the objectives that we would like to really cover here, we'd like to do therefore is, it's best accomplished if we could read a data set into R and then find out which are those variables that are continuously or other continuous variables, which are kind of the type of that variable is double, and then we would attempt to show you some numerical summary that R will give you if you ask for them, and also what are some of the strategies that you can use to have a visual summary of the distribution of that particular variable in R. So those are the things that we are quite interested to show you here. So let's do the first thing, that is read a data set, and then we identify which variables are continuous variables. So let's do that first. Now here is a data set, and in that data set that we've been using for some time, and you may be familiar with this by this time, is about a data set where we are looking at bicyclists that are passing by some static motor cars, and the motor cars, of course, you know them by their vehicle name and their type of vehicles, and their passing distances are noted, and etc. So all these things. I mean, it's a simple data set that also contains whether the bicyclists are wearing helmets or not, and so on and so forth. It's kind of a behavioral science study. So what we're going to do here is that data set was, because it was kind of a social science related project, the data set was an SPSS data set. It's called psychbike.sav, and we have obtained that data set, and we are now going to read the data set, very simple data set, by invoking the foreign package and installing the foreign package, and then calling the library of the foreign package, library foreign. Then we're going to read the data set, and then now what we have done is we have created a vector. That vector is called cont_var, or continuous variables, and this is going to again call a function called isApply, which is going to apply another function which is type of to the data frame, which is my data, which actually contained the data set there. And in the language of R, a continuous variable is quite often given the type of double, which means you think of a double type variable as one in which you can have a decimal point, and you can have number in double digits, and so it'll have that's how it is conceptualized. So that is a continuous variable, an easy way to identify, and we let R to identify them for us, rather than we noting that something is a continuous variable and then specifying it. We let just R figure it out. So accordingly, we set our working directory, we called the library foreign, we read the data, and then we ran the continuous underscore variable, and then we ran our type of throughout the data set, and it gave us that there were like 4 variables that were returned as continuous variable. The first one was hour, which was kind of the time component that was present. Then helmet. Now helmet, R decided that it was kind of a double and therefore a continuous variable. And this is fallacious, because you will see that it is essentially a 0 and 1 when we will summarize them. And that's also another factor why you need to use an omnibus summary function, letting R decide for us as to what that could be. The distance from the curb, we'll take a look at this, and R decides that it is a double or a continuous variable, and a passing distance, which is again according to R it's a double, because that's the way in which it was encoded. So that's what R is telling us, and sometimes it does happen that when we enter data into a rectangular matrix, quite often we do not differentiate between, say, putting in an integer, and then often that integer contains a decimal point, and statistical software such as R often interpret them as double variables, and therefore when we only use them and then we would like to find out whether that's a continuous variable, we may be fooled, or R may trick us into believing that these are continuous variables. But whether these are or these are not, you need to find out for yourself. And this is exactly where a summary function becomes very, very important. And this is why you should be very careful about using the summary function. So what's the best way to do the summary function? Now, this is where what we're going to study next. We're going to numerically summarize the variables. What that means is we could let R to summarize the variable. There are two ways to do this. One is you can subset that particular variable from the data frame. For example, let us say you are interested to find out the summary statistics of the continuous variable, the passing distance. So you could subset passing distance from the data set called my data. So you put my data, then put a dollar sign, and then next to the dollar sign you write passing distance. So passing distance will be extracted from the data frame my data, and then you can extract summary statistics for that. But more commonly, when we are interested to find out summary statistics of the entire data set, we are not interested to find out the summary statistics of only one variable. We would like to see that we would get the summary statistics for the entire range of variables that we are interested in. You can do the same thing with R, and it's quite an interesting way of doing it. What you do is you use the same summary function, but this time instead of writing like sapply or something like that, what we do is this, that we use the summary function. So I would say summary, and we open a parenthesis, close a parenthesis, but instead of just typing or hand typing these variables one by one, we subset. And how do we subset? We could subset, or we could write, for example, the entire data frame, and it would summarize each variable one by one of the data frame. Or we could subset the data frame, and when we subset a data frame, the way we do this is we write the data frame, then open a square bracket, and in a rectangular data frame, that opening and closing of that square bracket actually helps you to subset either rows or columns. If you want to subset rows only, then you mention which rows you want and then put a comma next to it. So you start with the rows and then put a comma. And then R is going to subset only that number of rows. Say for example, if you wanted to put together like 5 rows, then with C, which is catenation operator, as a function 1:5. So it'll give you the first 5 rows. But as it happens, in this particular case, we are interested to find out the subset of the summarization of each of the variables column-wise. the variables themselves. So we put the comma first, and then we put C, and then we say, okay, give me the individual variables. In this particular case, our helmet distance from curb and passing distance, and R will oblige us. We store the result of everything that we have done into an object which is known as sum underscore cont, which is essentially an abbreviated form of that. We are going to keep the summary of the continuous variables. And when we do this, we see that R gives us, in its own way, some measures of central tendency and dispersion. So what is the central tendency it reports us? It gives us the median and the mean. You can see for hour it does not really matter because the medians and mean are very, very close together. You can also see that for helmet it's slightly different, and it says that a median is 0.0 and mean is 0.4879, and then the minimum is 0, the maximum is 1, and the third quartile is 1 as well, and the first quartile is 0. That obviously flags a bell, because that says that tells us that something's wrong going on here. Okay, so even though helmet is treated as a continuous variable, it is probably not, which means that helmet has got only two values, 0 or 1. So the mean here basically tells you that about 48.7% people had worn a helmet if 1 is equal to wearing a helmet and 0 is not. Obviously, we cannot take helmet to be really a continuous variable. So this is something that you need to really understand when you read summary statistics, that even though R gives you and pumps out a lot of stats, that does not necessarily mean that R is intelligent enough to understand that this is a really continuous variable, the other is not. You have to make judgments with this. Likewise, if you look at the distance from the curb, you see something very, very odd. The minimum is 0.25, the first quartile is 0.25, the median is 0.5, the mean is 6 to 7, the third quartile is 1, the maximum is 1.25. So there's something going on there. It's essentially a categorical variable kind of masquerading as a continuous variable. Do you see that the importance of writing or asking the summary in this way? Because we could probably know that it is a truly continuous variable, and we could, for example, passing distance. If you take a look at the minimum, the maximum, the third quartile, the first quartile, the median, the mean, it is quite obvious that this kind of follows a pattern of what is a plausible a continuously distributed variable, but the others are not. And this is one of the reasons why you should ask for a summary and carefully scrutinize that there is something wrong going on there. And this example therefore was deliberately chosen to illustrate some of those points. And otherwise, you can just take a summary of one particular variable and take a look at this and see that, look, this makes sense, this doesn't make sense. So in this case, out of those 4 variables, we can quite clearly see that only one of them is a truly continuous variable, and that is passing underscore distance. But note that in this routine, when you ask R to put out a summary statistics, then R gives you all of these, but it does not give you a variance or a standard deviation. That is something that you will have to calculate yourself, or use the var or the ASD function to extract those numbers. A very common and popular way of looking at summary statistics of continuous variables is to order from most statistical packages a routine which is known as 5-number summary. In the language of data analysis, 5-number summary essentially means that you should ask for the minimum value the first quartile, the median, the third quartile, so that you can calculate the interquartile range, and a maximum value. And that 5-number summary essentially gives you kind of a range and a central value, which is kind of the real center, like the 50th percentile, the median. And it does not provide you with the mean. R gives you that. So, and that is known as a 5-number summary, and we say that 5num. The function is called 5num, and it's one of the base functions. So you'll say 5num, and then you mention the particular variable. So in this case, we are interested in passing distance out of the data frame of my data, and we do this. Unlike summary, 5num is a function which will take as a parameter the particular variable that you're interested in. Therefore, if you wanted to have 5-number summaries of more than one variable, then you'll have to subset it accordingly or use the apply functions to get them. And note that unlike the summary statistics, which gives you a neat header and named parameters like minimum, first quartile, median, mean, third quartile, maximum, it assumes that you know them. In other words, you could actually then generate a data frame if you were to use something like an isapply, and it would give you, one after the other, and these 5 numbers in that order. That is the minimum, the first quartile, the median, the third quartile, and the maximum value. And then you could actually then manipulate the third and the first quartile in order to get the interquartile range as a measure of dispersion that is quite useful for us. So this is how you numerically summarize the variables. The things that get omitted from this is the use of mean and standard deviation, which you can otherwise use. So for most purposes, a continuous variable that gives you these kind of numbers are quite useful for you to actually make some sense and numerically compile the summary stats. So let's take a look at the visual aspect of it. And here we're going to provide you with 2 charts that are very useful. The first one is called Boxplot of continuous data. So let's move on to the second thing, that is a Boxplot of a continuous data. In one of our previous lectures, we were looking at the fact that when you start cleaning your data, you would like to take a look at 2 things. You'd like to take a look at the fact that your data contains incongruous numbers, or it contains outliers. But what is important here is this, that you'd really like to see what does the distribution look like. So you could get the same 5-number summary, but this time it's in a more visual manner. And this is exactly what the Boxplot does for you. What is interesting though in Boxplot is you can have 2-way boxplots, you can have more than one boxplots, and you can actually have one single variable boxplot which will give you the minimum, the first quartile, the third quartile, the median, and the kind of, and then what it does, it gives you the minimum and the maximum, but there is a trick. It actually draws to whiskers, and these whiskers are drawn at around 1.5 times the interquartile range from the median. Again, the whiskers are drawn taking median and then 1.5 times the interquartile range of the median. You can actually verify them from the figure itself. Now, these whiskers are kind of the limits. So if, this would give you a sense that any value that lies beyond the whisker is an outlier. So it's something that's kind of conventional and these are outliers. You could see that there are some outliers that are beyond that range, and there's only one value which is below the lowest range that the R program calculates. Okay, so Boxplot is a very, very good and quick way to summarize the visually a single variable. Sometimes you can have it for more than one variable, but we've here only shown for one particular variable. Beyond this, for a variable to be so that you can make it to some good use, you'd like to see a histogram with a density plot, or also known as probability density plot, which is next. So a histogram with a probability density plot is asked for by using the hist function, and then you open and close a pair of brackets and put the name of the variable. You extract the variable from the data frame and use it. And you can see over here that it looks almost like a normal plot, but there is a bit of a skewness towards the right, which we of course had seen before with the box plot, that there were several data points that were above the expected high value. So there were some outliers. You can see that the passing distance. The last thing that we're going to show here is this, that you could actually get a visual summary of two variables together using nothing but a scatter plot and using a linear function to show how they're associated with each other. And this time we have used an inbuilt dataset called cars, and we've used them to show that the distance and speed are related one with the other. And you can see that in the summary, a very, very quick way to do that is to show a relationship of each other. Okay, we'll probably revisit that, and we have already learned about these things in our linear model. So I'm not going to put a lot of emphasis, but beyond stating that you could, if you have two continuous variables, you could see them together related like this. So let us summarize what have we learned. So we have learned that we learned some of the key principles of summarizing continuous data. We learned that it is quite easy to actually identify continuous data in R, but that does not mean that R always does a good and faithful job of flagging continuous data. You have to be quite discerning for this. We have learned we could numerically summarize one variable, and we could visually summarize one variable. We could use the summary functions and the 5 num functions, and we can visually analyze two variables together. So that's so much for this particular lesson, and thank you very much for listening to this, attending to this tutorial. Please use the codes to practice more and more. Thank you very much.